Well, hello calculus students and seekers of truth. In this video and the next several videos, we will talk about integration or taking antiderivatives of the natural log function and the exponential function. So first, let us review just a little bit here. We've got a function f of x equals the natural log of x. That means f prime of x would be equal to 1 over x. Right? And this is review. If you don't know where that comes from, look in one of the previous videos where we talk about the derivative of natural log. However, one thing we should be clear here is this restriction only applies, this function, this derivative only applies with the restriction that x is a positive number. You cannot take the natural log of 0. You cannot take the natural log of a negative number. So let's just look at a very, very quick graph of this. So if I have an xy coordinate plane here, then my natural log function looks something like this. Right? So this is ln of x. And then the derivative of that, 1 over x, looks something like this. Right? This green part here is 1 over x. And there's also another piece to the 1 over x function here, but we don't use it. It's not applicable in this case because the natural log function has a domain, right? Let's review real quick here. It has a domain. The natural log function has the domain of 0 to positive infinity, 0 exclusive. So the derivative of the natural log is 1 over x only when x is a positive number. This will become important in a little bit when we talk about the antiderivatives. Next, the function here, g of x equals e to the x. Its derivative is, of course, itself. It's very special, right? E to the x is the only non-trivial function whose derivative is itself. All right. Therefore, we can make this leap from our review to here. The indefinite integral of e to the x, or the antiderivative of e to the x, is itself plus a constant. So C here is, any constant. Right. Now, the antiderivative of 1 over x is going to be the natural log of x plus a constant. Okay? But remember, this only works. Remember that 1 over x is defined for all real numbers except 0, negative and positive numbers. Natural log is only defined for positive numbers, so we have to make this restriction. This is when x is greater than 0 only. And so when we take the antiderivative of 1 over x, we run into a slightly trickier problem. What happens, all right, for when x is equal to, or when x is a negative number? When x is less than 0, what's the antiderivative? We can't use the natural log of x as the antiderivative because natural log of x only works and only accepts positive numbers. So what we're going to do here is we're going to apply a trick. We're going to use something called the change of variables, or in other words, using integration by substitution, in order to deal with this problem of the antiderivative of 1 over x when x is a negative number. So let me make u here equal to negative x. Okay, so whenever x is positive, u is negative, and so on. Okay, so if we do this, we get du dx, right, is equal to -1, and du is simply equal to negative dx, right? And now we can take this problem here and take the second part of this. When x is a negative number, we have the antiderivative of, instead of 1 over x, we're going to have 1 over u, right? And instead of dx, we're going to have negative du. So negative du is equal to dx. Okay, so we're only talking about the cases where x is a negative number. So we end up with negative u. Hold on a second here. All right, let me try this again, because I think if u is negative x, then we're changing x, so that would be negative u. And instead of dx, we're going to have negative du, right? And then the negatives here is just cancel. And you might say, well, what the heck is going on? We're not doing anything really special here. All we're doing here is changing all the u's to the axis. But a little bit of patience, and we'll get to where what we're going for. So we take the antiderivative of 1 over u, and we get that's the natural log of u plus a constant. All right, but let's not forget that u is equal to negative x. So this comes out to be the natural log of negative x plus a constant. And this is our final answer. So when x is a positive number, then the antiderivative of 1 over x is the natural log of x plus a constant. When x is a negative number, then the antiderivative of 1 over x is the natural log of negative x. So this negative x here allows x to have negative numbers. So if x was negative 5, then you would have natural log of positive 5, and all is well. But this seems very clunky to have two separate cases of antiderivatives for a singular function. So we can actually combine these two ideas together, the natural log of x when x is positive, the natural log of negative of x when x is negative. Okay? And we can combine that simply by saying the natural log of the absolute value of x plus a constant. Okay? Now, let me go a little bit in depth here, or not, maybe in depth in some review here, because what is the absolute value of x? Well, the absolute value of x is really a piecewise function. When x is a positive number, it's just equal to x. Right? And when x is a negative number, then it's equal to negative x. And so if you were to graph this piecewise function, you would in fact get the same thing as the absolute value function. So when we have a negative x when x is negative, and a x when x is positive, that's the same thing as saying as the absolute value of x. So we can sum this up by saying that for all cases of x on its domain, the antiderivative of 1 over x is the natural log of the absolute value of x plus a constant. All right. So as far as algebraically, this works out pretty nicely. It's easy to memorize, but make sure you fully understand why the absolute value is necessary for the cases of integrating 1 over x.